Hi, so today we're explaining about power of log. So now let's look at the power of law of log. This formula will allow us to move the n, the exponent, in front of the log as a multiplier. This makes so much easier to solve question and where the unknown is in the exponent, because instead of working with x to the power of n, we can deal with n times log x. So first question we'll have log base 2 of a to the power law of log. The rules say that if you have a log of number raised to a power, you can move the exponent in front. So for our example, log base 2 of a to the power of 5, we take the 5 and move it in the front of the log. So it's going to be 5 times log base 2 of 8. Now we just calculate the log base 2 of 8. Since, as I mentioned before, 8 equal to 2 power of 3. So we have log base 2 of 2 to the power of 3. Then we cancel out using the first method. Now we still have the exponent. We give the exponent, which is 3, and then we times to 5 in front, which we got 15. The change of base formula. Now we have an equation like 2 equal to 1.05 and power of t. So basically we don't know the power yet. We could have written this in log form as log base of 1.05 of 2 equal to t, but unfortunately there's no easy way to change 2 to the power with base 1.05, and you can't just type on your calculator to evaluate, because most scientific calculators can only evaluate log in base 10. So we have to use the power log of log instead. Anytime you want to evaluate a log that is not base 10, such as log base of 1.05 of 2, you can use the change of base formula, which I'm trying to explain right now. We have the formula log base of b of m equal to log m divided by log b. The b is the base of log, which is represent the base 1.05, and the m is the number you're taking the log of, so which is number 2. So now we have log 2 divided by log 1.05. Now we are going to use log to solve a real life problem with investment. The question is, you're supposed to invest $250 in an account that pays 4% interest, compounded annually. The total amount in the account after years, which is represent t, given by this equation. A equal to 250 times 1.04, and with the power of t. Now we have to find the t because we don't know the t yet, which is they are asking how long it will take. Yes, so the question is, how long will it take for the investment to double? We're starting with the amount of $250. Now it's asking you to find a double amount, like how long it takes to earn the double amount, which means it's going to be 250 times 2. Now we have A equal to 500, because A represent how much money you will have in the account after a certain number of years, so include the interest. Now we have the equation 500 equal to 250 times 1.04 with the power of t. Now we move the 250 to the left, which is 500 divided by 250. We have 2. So now it's 2 equal to 1.04 t. Since the t is the exponent, we cannot solve it directly. This is where log come in. Now you have to put the log in both sides. And then we use the power of law of log, which is log base of b of x power of n equal to n times log base of b of x. This formula allows us to move the exponent in front. So it's going to be log 2 equal to t times log 1.04. And now we separate the t. We're going to move the t into the left side. And now we let the log 2 divide by log 1.04. Then use the calculator. So the t is approximately 17.7. Therefore, it takes about 17.7 years for the investment to double. This is the real life application example because it shows how log are used to calculate growth over time. And people use this to figure out how long it takes the money to double in a bank account, or to know how is the investment grow, or how long it takes for saving to reach a goal